Good afternoon, sir.
Hello, hi, good afternoon. Thank you for having me here, Dr. Pancha.
Yes, thank you.
Good afternoon, all of you. It gives me immense pleasure to introduce to you all Dr. Abhishek Srivastava, sir. Sir is an associate professor in the discipline of computer science and engineering at Indian Institute of Technology, Indore. Sir has completed his PhD in 2011 from the University of Alberta, Canada. Sir's group at IIT Indore has been involved in research on service-oriented systems, most commonly realized through web services. More recently, the group has been interested in applying these ideas in the realm of Internet of Things. The ideas explored include coming up with technology-agnostic solutions for seamlessly linking heterogeneous IoT deployments across domains. Further, the group is also delving into utilizing machine learning adapted for constrained environments to effectively make sense of the huge amounts of data that emanate from the vast network of IoT deployments. Sir has served as head of the Department of Computer Science and Engineering at IIT Indore and subsequently as Dean Student Affairs at IIT Indore. Prior to joining IIT Indore, Sir has served as an assistant professor at the Rose-Hulman Institute of Technology, USA. We welcome you, sir, and with this, I invite you for your lecture.
Thank you, Dr. Srivastava, for the introduction. So what I'll do now is, can I share my screen?
Yes, sir.
I'll go ahead. Okay. Please tell me if you're able to see my
Yes, sir.
screen.
It is visible, sir.
Is it full screen now?
Yes, sir. It's full screen.
Okay, perfect. So, again, thank you, Dr. Panchal, for inviting me to do this talk. As I believe the theme of this particular course is Internet of Things. So I'm talking about something that is somewhat related to Internet of Things. It's you could call it a subset of Internet of Things that I'll be talking about. Give me a second. I just want to get rid of this hide thing over here. Yeah, I think this should be okay. Okay. So what I'll be talking about is a web of things, which, as I said, is a bit of a subset of Internet of Things. All right. So I always want to start with this. I know I'm assuming everyone here, all the participants are, conversant with the internet and conversant with computer science as a subject. So maybe these are very trivial initial slides, but I always enjoy starting with this, and that is that the one big question is, what is the internet? All right. So we all know. I mean, that's my son, my 10-year-old son who's 10 years now. He probably knew about the internet when he was 4 years old also. So I mean, that's how internet that's how pervasive internet has become today. All right. But there is one thing that there's one mistake, if I can call it that we make, is we tend to always think of the internet and www, the World Wide Web, as being synonymous, or as being pretty much the same thing. For all practical purposes, they are synonymous, but in reality, they are not. I mean, technically, they are two different ideas, two different concepts. All right, so the internet is really, if you look at the picture, that's an old picture that was taken in 2010. It's probably become much more complex and much more extensive now. But basically, the internet is the connection that exists between computers all over the world. I mean, in very simple terms, that's pretty much what the internet is. The infrastructure that enables the connection of computers all over the world. Okay, and so there are different ways the connectivity. You've got all these all kinds of cables, optical fiber, and then you've got wireless communications, wireless connectivity, etc. All of these together form the internet. That is the basic infrastructure based on which we have all our computers. I mean, the fact that I'm doing this presentation, the internet is making it possible. The fact that my computer over here in my office in Indore is connected to your computers in some ways, and the internet is making it possible. So again, the internet is the infrastructure. World Wide Web is the layer of applications on top of this internet. Okay, so when we say, although we use the internet and www synonymously, but the fact of the matter is the World Wide Web, when I say www, the World Wide Web, talking about the bunch of applications that are on top of the internet. It's not the bare bone infrastructure, but it is the applications that we make use of. So this is very important for one to understand this distinction, and it is especially important from the point of view of the talk that I've just started. I mean, I'm going to talk about Web of Things, so it's very important that you understand the distinction between internet and World Wide Web. So we probably know all this, but it's very important to spell it out, really. So it's a basic. So these are two totally different concepts that exist. I mean, this Google Meet is an application that is running on top of the internet. And another very important point, I keep saying this to friends of mine, and some of them don't believe me, is that whenever we talk about the internet, the I should be capital, okay, in the internet. Whereas if you say an internet, so the meaning of the word internet is it's a network of networks. All right. So if I have a computer in my office, I can connect it to the computer. It is connected to the computer in the next office. And this network of two computers in two adjacent offices may be connected to the network of computers in the laboratory in the computer science department here. So that would become an internet with the I being small. But when we say the internet, the internet that we're talking about that connects all the computers in the world, we tend to use a capital I. So it's just a bit of a, I like saying this, but because most of you probably know this, but in case you don't, it's very important for you to realize this. This is a very important thing. You should always use the capital I for the internet. You're talking about the internet as we use it nowadays. Okay, so that's pretty much that's the distinction aside. Now, the internet or the World Wide Web, as I said, we tend to use these terms interchangeably. So I'll just use the internet for whenever I say internet, you probably can assume that I'm talking about World Wide Web, which most of us do. So the internet, as we know it comprises a large number of applications. All right, so we are used to it. We've been doing so many things using these applications. There's Facebook, there's Gmail, there's Google Meet, there's YouTube. All of these applications are there on the internet. That is pretty much what the internet is all about. All right. And the one thing that is, if you look at all those applications over there, is all of those applications are virtual applications. Okay, what we mean by that is that they are behind our computer screens in very simple words. You cannot touch those applications, right? Those applications are there, you can use them, you can feel them, you can enjoy them, you can contribute to them, but you cannot really touch them. Okay, so it's basically, if you're a computer science student, that is the difference that they say that exists between hardware and software. Hardware is anything that you can touch. Software is something that you cannot touch. I mean, that was a very sort of a laymanish kind of a distinction, but that is probably the most important distinction that exists between hardware and software. Software is something you cannot touch, hardware is something you can touch. And here also, most of the applications, the way we are more used to them on the internet, on the World Wide Web, are virtual applications, are softwares. Really. We cannot touch them. We can feel them, we can use them, we can contribute to them, we can add to them, we can create them, but we cannot touch them. All right, so those are what the internet was all about. But now what is happening is, and so obvious, is that now we are able to sort of extend the internet beyond that virtual space into the physical space. Okay, now what's happening more and more is, now we are able to, through various communication technologies, various fancy things out there, we are able to go beyond the computer screen and connect real physical objects with the internet. Okay, so it's you have nowadays we have cars that are connected to the internet. So there's so many things that your car can do through the internet. You can actually turn on your car through a voice command while you're sitting inside your home. At least that's what a lot of advertisements show. So you can do so many things. There are these watches that are connected to the internet and a bunch of things. I probably don't even use 1/10 of the things that are available that are connected to the internet. And that is what is basically Internet of Things. And then as I said, these first few slides are going to be very trivial and you'll probably think I'm wasting your time, but it's important to understand what Internet of Things is all about. So it's nothing but the internet going beyond the virtual and through various technologies connecting physical objects to itself. So now not just computers are connected to that wide network that we call it the internet, but now small things are also connected to the internet. So, I mean, a lot of you may be having those Alexa devices or those Google Home devices where you can actually turn on a light bulb, just by giving a command. The light bulb is connected to the internet, and that is a very simple and a very useful example of an Internet of Things deployment. All right, so now that's all very nice. A few examples. So what is an Internet of Things deployment? Again, let us say I have this lamp, and what I do is through some mechanism, I'm not going to go into those details, and those are very basic deployment mechanisms really. If we connect some sort of a sensor, an actuator, and a transceiver, a transmitter and a receiver, a device that has all of these, it becomes an Internet of Things deployment. So now we can say that maybe this lamp of mine is connected to the internet. So what I can do is, let's say I'm sitting here in my office, and let's say nobody is there at home, and suddenly I realize, oh, I forgot to turn off the lamp. I was in a hurry in the morning to get to the office for a meeting, and all I do is I open up my browser, I send out a command, and it gets triggered over there, and there is an actuator that turns off the switch, maybe pulls the switch or whatever, howsoever the mechanism is. And that's a very useful deployment, a very useful facility that we have. So it's very nice, very interesting, very, we used to maybe even just 10, 15, 20 years ago, used to watch movies where you could do all of these things, but now it's very much a reality. Okay, and Internet of Things is basically what is making this reality happen. Something that is an amazing contribution of technology today. So that's what's happened, really. The way there's been a proliferation, really, of Internet of Things devices. So we are in 2021 right now, and we're looking at something like 30 billion IoT devices, which is a very large number, very, very large number. And so it's basically devices that are connected to the internet. These are statistical figures, but I mean, they're pretty close to the actual numbers. And imagine, compare that, the human population probably in the world is about 6 billion. So 5 times that number of devices is connected to the internet, which is amazing, which is mind-boggling, and it's almost like almost everything around what we use today nowadays is out there, and that's connected to the internet. And this is expected to really rise, and by the time another 4 or 5 years, we'll go up to 70 to 80 billion devices, which is huge. And so it's going to become a part of our lives. Okay, it's going to be something that's there. It's very much, it is already there, but it's still not, still not totally pervasive. There's still large pockets that are not very familiar, but all of that is going to change very soon, and we're going to have a very large number, very, very large number of IoT devices. Okay, I'll just pause over here, and if you are not able to see my slides, please interrupt me, because I am not able to see what you are seeing. All right, I have my entire full screen in front of me, so I am not sure if it's going across. So can you see and hear me properly, everyone? If one of you can just say yes or no, whatever.
Yes, sir, it is visible.
Good. So thank you. So in case it goes off, please let me know, because I am not able to see that Google Meet thing. I have this thing full screen. So it's not available. If you cannot hear me, just let me know, and I can maybe repeat something, or I can rectify whatever the problem is.
Sure, sir, sure.
Thank you very much. Okay. So basically, that's what it is. We have a very large number already. We are, and the thing is, it's happened really rapidly. I mean, if you look at 2012, it was just 8 billion, and now that's gone up to around 4 times that number in maybe another 8-9 years, and it's probably going to go up to maybe around 2 to 2.5 times that number in another 3 to 4 years, which is amazing. Which is an amazing increase. All right. So a few examples, again, I'm going on and on about this. These are a few examples of IoT. So one example is this, something that's very much a reality in India also. And that is that we have these smart, these toll booths now have these RFID readers, and we need to have these RFID tags. Otherwise, we have to pay double if you're paying in cash. So which is really nice. I really like it. I mean, just everything gets debited from my Paytm wallet, and it's a very nice to have feature. So it's something that has become very commonplace now. I mean, if we talked about this another maybe just 5 years ago, it would be like science fiction, but now it's so much a reality, and we've become so much used to it. The cars just coming in, the toll thing opening up, the boom barrier, whatever you call it, opening up, and we going across. So that's a good example. Another one is, of course, smart homes. Smart homes are very, very common nowadays. Even our mobile devices have facilities for, this Google Assistant that we can connect to various devices in our houses, or something like Amazon Alexa, which is very popular. And you just tell Alexa to do something, Alexa does it for you. Sometimes it goes beyond what you want it to do, but then I guess that comes with the facilities that you get. But in general, I think it's a very, very nice to have. It's a nice, very nice feature to have around the house, where a lot of things get done. I mean, most of us probably just use Alexa for listening to our favorite music, but then it can do a bunch of other things. It can be connected to our televisions. It can be connected to our refrigerators, our light bulbs, fan, etc. It's very nice. It makes our houses smart. So that's another very common example, and something that we can actually relate to. Now we're probably coming to, now all of this, of course, whatever I've talked about until now is something that most of you, I'm sure, already know. It's all very trivial. Now we'll talk about something that's, more about, probably more relevant, and that is that IoT the way it is today. All right, so I'm talking about the current state of the art. I'm not saying that it's not beyond that, but in general, the mass adoption of IoT, the way it is it's meant for human consumption and for human control. Like, what I mean by that is, if I just go back to that example that I took, is if let's say that I want to operate that lamp, which I forgot in the morning while coming to office to turn off, I can use a browser, open up a browser on my computer or on my smartphone, and I can turn off that lamp from sitting in my office. So it's all very nice, but the thing is, it requires human intervention. Okay, so it's most of the IoT deployments that we have today are meant for human consumption. It is meant for it is built in such a manner that human beings have to intervene for something to be done. I'm not saying there are no deployments that can do things otherwise, but mostly in talking about majority of the deployments are that way. And the second thing that happens is we have deployments that are very tightly coupled. What I mean by tightly coupled is that there are if you are using a particular technology in a certain in a certain area, let's say your home, you are using the Amazon ecosystem. Okay, so you have an Alexa device. What you have to do is you have to have devices that are compatible with Amazon. Okay, so you have to have a light bulb that belongs to the Amazon ecosystem. You'll have to have a microwave, all the examples that you have over there in that picture. All of those have to be compatible with the Amazon ecosystem, otherwise it will not work. Okay, so basically what happens is you get married to a certain to a certain ecosystem. So if you have Alexa device, if you have Amazon at home, you will probably want to get everything that is related to Amazon. But if you have, let's say for example, you are married to the Amazon ecosystem, and then somebody gives you a light bulb which is compatible with Google. Now that light bulb cannot work with your Amazon ecosystem. And that is an example of tightly coupled systems. All the systems are very tightly coupled. They are not loosely coupled. What we mean by that is there is no plug and play sort of an architecture where, let's say, I have a light bulb that belongs to one ecosystem. I have an Alexa device that belongs to the Amazon ecosystem, a third thing that belongs to the Samsung ecosystem, or whatever. I am not even aware of all the IoT deployments and technologies out there. We cannot seamlessly connect all of these. We have to have things belong to a single ecosystem. Okay. Now that is what is tightly coupled, and that is how IoT is today. Okay, it's all very tightly coupled. The technology to make everything, I'm not saying that you do not have connections happening, but it requires very hard-coded solutions. So if you want to, let's say, turn on a light bulb using an Alexa device, you can have that be done for you, but then you have to bring in a developer who will write some code and make your light bulb compatible with your Alexa device. It is not plug and play. It's not like I have this bulb which belongs to Google, I have this Alexa device, and seamlessly they're connected to each other. That in many ways technology agnostic infrastructure in IoT actually currently is not there. And at least it's not there in a mass scale. It's there maybe, but it's there in very small islands, and in overall a majority of the deployments are not that. So that is the big the limitation that exists. Now, an ideal IoT scenario is one where, number one, as compared to ones, the IoT deployments that were meant for human consumption, in an ideal IoT scenario, you have seamless machine-to-machine connectivity. What that means is, you don't necessarily need to have a human being intervening in controlling an IoT deployment. It should be done seamlessly without an interface. So let's say for the simple example that we took of a lamp over there, a better system would have been if there was some sort of a heat sensor near the lamp, and the heat sensor once, because the lamp has been on for a time beyond what it should have been on, the heat sensor triggers an unexpected sort of a scenario. It sends off a signal to a computer system somewhere, and that computer system realizes that the lamp should not have been turned on. It sends a message that please turn it off. So there is some bit of analytics happening, some learning algorithms doing the thing, and very seamlessly all of this is connected. Now, I'm not saying, again, I'm repeating this, I'm not saying that this does not happen. This probably happens, but it is not the norm yet. Even now, most of the things that we have right now in the world are deployments that are human driven. A human being has to be there in the loop. But this is a more ideal sort of a scenario which will make things even better for us. Okay, that's the first thing. That's the first ideal IoT scenario that we need to work towards. The second scenario is a loosely coupled deployment, ecosystem. Now, what that means is the example that we just took of, let's say, all your devices belong to a certain ecosystem. You cannot have devices from another ecosystem communicating with them seamlessly. No, you don't want that. An ideal scenario is when everything is very loosely coupled. So it's a plug and play sort of a thing. So our lamp over there, I can very easily connect it to my television and connect that to maybe a speaker out there, or I don't know, that gaming device, gaming console, everything. So all of these should be such. All of these may belong to their own specific technologies. But what we want is, we want them to be all communicating with each other. And this is it's not just about the example, the smart home example that I'm taking, which is actually, it's an insignificant sort of an example. But if you think about the applications that loose coupling will give rise to, it's incredible. I mean, amazing sort of applications. So if you look at a smart city environment, for example, and we'll have more and more IoT deployments happening. We'll have IoT deployments that will be related to your medical condition. So people may be having these small sensors that are embedded in their bodies in some ways, which will be sending out signals. And then there may be an IoT ecosystem existing in a hospital. And then these are two separate ecosystems, but these need to seamlessly communicate. So if you have a loosely coupled system, some sort of a system that permits loose coupling, this is something that is going to happen seamlessly, and the possibilities will be endless. As compared to a tightly coupled system where your home, your body medical system, that body area network is what we call it. A body area network belongs to one technology. The hospital infrastructure is a different technology. Then you'll have to have somebody coming in, have some sort of a hard-coded system that enables that sort of a connection, which is there, which is possible, which is going to work, but it will not be an ideal scenario. You want things to be very, very normal, very simple, very, immediate sort of a thing, immediately deployed. So that is going to happen if you have some sort of loose coupling. Now the question is, how do we make these things happen? Okay, how do we make this happen? Now, what sounds familiar? I don't know why I have that on top, but I don't know how many of you have backgrounds of computer science. If you do, you probably know the difference between these. But just for the sake of people who don't necessarily have a computer science background, who do not know, the big question: what is the difference between web applications and web services? Okay, and I've deliberately brought this over here because I want to tell you the difference between IoT and WOT, which is I'm actually going to go to very soon. So what are web applications? What are web services is a question. A lot of times I've seen a lot of people, especially people who are not related to computer science, think of the two of these as pretty much the same things. Okay, a web application can also be called a web service, is what a lot of people say, which is not true. Okay. So what are web applications? Oops, sorry. Okay. So these are web applications. Okay, we know about these. And Times of India, the app that we have, whether it's a browser-based Times of India or it's the app-based Times of India, whatever we use, those are web applications. Okay, and the thing about web applications is these have, they're based largely on HTML. Okay, why are they based largely on HTML? Because these are meant for human consumption. Okay, so if you have Times of India being there, because it is meant for human consumption, you want it to look very nice. Okay, you want it to have nice colors. So Times of India, if you open up the app, it has a lot of red color. It has very nice and very good quality print out there, and it has a lot of these links, etc., that you can click and you can actually go on to the next article or something that is related, and it has very nice pictures, etc. It's something that is very it appeals a lot to the human eye. And that's what, a lot of these applications, when they develop web applications, they're trying to make this happen. And this is all done by being based largely on HTML. You have a lot of other technologies in play, but it is all based largely on HTML, because HTML has a lot to do with how it depicts things to, how it renders things so that they look very appealing. So you can put in colors, you can have a large text, you can have bold, you can have italics, all of these things HTML permits you to do. It makes things really pretty for the human eye, and that is what web applications are all about. So again, meant for human consumption. Facebook is something similar, lots of pictures, and nowadays you can also create content on Facebook. You can do your own posts, you can put up your own pictures, and you can do whatnot. And all of these are done in a very nice and very friendly sort of an interface, and they're making it better every day. I mean, earlier I remember Facebook was more of a static sort of a system, and now it's become so dynamic. I watched one video on Facebook, and all the other videos that follow are videos that will probably impress me. Because it's very interesting the way they present the things. There lots and lots of research going on, and it's all very nice. So these are all examples of web applications. Now we have a web service. Now, a web service is meant not necessarily for human consumption, but mainly for consumption by other applications. Okay, so let's say, in some cases we want all of these Times of India, Facebook, all of these have a web service equivalent. I mean, one word that may probably sound very familiar to a lot of you is APIs, okay, application programming interfaces. So these are basically, all of these come with their own APIs, and what they permit a person to do is, if I am writing a program, and I want that program to, sort of maybe pull the latest news as part of. Let's say I'm writing an application for IIT Indore, and in that particular application that I'm writing for IIT Indore, I want the latest news from Times of India to also be sort of flashing, because this is the latest news. Maybe some people like that. So in the institute website, they also want the latest news from Times of India. Maybe latest news related to Indore sort of flashing in that website. So what I can do is I can use these APIs of Times of India, and I can pull that information and I can make use of that in my website. So that is an example of a web service. Okay. So a web service is usually based on XML or JSON or any technology agnostic solution offering. So basically what it does is XML, the difference between HTML and HTML is more about making things look very pretty, very nice, very beautiful, very colorful, very etc. But XML is more about arranging content in a logical manner. Okay, so it will arrange it in a very, very logical manner, often as a tree structure, a bit like a tree structure, where if another application tries to get content, because it is so logically placed, all the content is so logically placed, the application can very easily understand what it is all about and make use of it. Okay, so that is a web service. And the reason I say technology agnostic is it does not matter what technology. Let's say the Times of India website, the server that they have out there, they use a certain technology, and my application over here, I'm using a totally different technology. It will not matter as long as something is in a technology agnostic language like XML or JSON. I can very easily different applications, because it's all very logically structured, irrespective of the technology. You can pull that information. We can make sense of it. The applications can pull that information, make sense of it, and actually use it in ways that are convenient for them. Okay? So the thing that's important is web services are meant for consumption by other applications or other machines, if I use a very simple term, whereas web applications are meant for human consumption. And what is happening is a lot of these applications, so mainly earlier when the internet started, really, there wasn't as much of emphasis on web services. It was all about web applications, making content for the human being, etc. So what people are doing more and more is making all of these legacy applications web-enabled in a manner that it can be used for other applications. So basically what they do is they have some sort of an XML envelope on top of these applications, and it becomes a web service. So maybe some of you have heard about WSDL, Web Service Definition Language, if I'm not mistaken. So that's an XML-based language that provides an envelope over these applications. And what it does is it actually pulls the information that is there in normal HTML-based language, and it offers it as an XML. So in a more logical manner, it is offered to another application that can use that information for putting together its own thing. So that's something that's how a lot of applications are getting converted, are getting offered as web services, in addition to being offered as web applications. So nowadays, if you look at it, Facebook has you must have seen Facebook for Developers. That is what it is. Facebook for Developers is the API of Facebook, which is meant for other applications to pull information from Facebook. Now, why am I talking about all of this? I mean, we're talking about Internet of Things. Suddenly, why did I move to web applications and web services? Now, the reason for that is pretty much the difference between Internet of Things and Web of Things. Okay? So just like web applications are meant for consumption by other human beings. Okay, so like we said, Times of India is deliberately made very nice and beautiful so that it can appeal to the human eye. In a similar manner, Internet of Things is meant for consumption and control by humans. So the example that we took of my lamp being left on at home, and I can turn it off from my office, but I need to be there. It's meant for human beings. It's a browser-based probably control system that they have. I can use it. But when we go to Web of Things, what we are trying to do is we're trying to make that connectivity, the human, be removed from the loop, and we were trying to make it more machine-to-machine connectivity or thing-to-thing connectivity in this case. Okay, so how are we doing that? It's very similar to what we were doing in web services. We have some sort of an API, some sort of an interface where the technology that we have that's running that IoT device is abstracted away, and a very uniform sort of an interface is presented to the internet. So it does not matter. So let's say my lamp belongs to a particular technology ecosystem, and my my Alexa device belongs to another technology ecosystem, and all of these are abstracted away. The specific technology is abstracted away by this uniform API, which is more technology agnostic. It does not matter what technology is being used within that particular device, within that particular deployment. These can be connected in a seamless manner, in a plug and play sort of a system over the internet by way of using these APIs. And this is what is Web of Things. Okay, it's not dependent upon the technology. It's dependent upon the the language that the internet understands. That's basically what it is all about. Now, I'm going to again digress a little. I'm going to talk about a very important API that is used now, which is very lightweight, and it's very important for APIs to be lightweight because you're using it on top of IoT devices, which are often deployed over resource-constrained environments. So it's very important for the API that you use for it to be lightweight. Okay, so we will see how what we use. And so one very important API that we have is these are known as RESTful APIs. So REST is stands for Representational State Transfer, and RESTful APIs are APIs that are very much in use nowadays. In fact, I believe Facebook and Google, all of these provide APIs that are RESTful in nature, and the thrust is towards using such kind of APIs for IoT devices also, converting IoT to WOT really. So what are RESTful APIs? So again, as I said, I'm going to digress a little. I'm going to explain. And another thing I'm saying, a lot of these things that I'm explaining over here, a lot of it is meant for an audience that may not necessarily be related to computer science. So if you are a computer science student, or you're a professional of computer science, you may find this boring, but I apologize for that. But this is meant for people who may not necessarily have a background in computers. So if you already know about all this, you may just enjoy yourself, and just it'll be a bit of a repetition, revision of concepts. Okay. So what is a RESTful API? Now let's take a simple example. Let's say we have Big Bazaar. We know about Big Bazaar. It's this very big marketplace that's very popular in India. In fact, recently in the news, because I believe Reliance wanted to take over it or something, and Amazon wanted to oppose that or something. It was some fight. Anyway, Big Bazaar was there. It was very important. So let's say Big Bazaar has a website. Big Bazaar does have a website, by the way. And there is this person standing over there, sitting in front of a computer. And the person wants to know something. The person is curious. And the person wants to know about customers of Big Bazaar for some reason. I don't know. Maybe the person is a marketing professional, or maybe a person is a student of marketing and wants to know about the customer base of Big Bazaar and makes that query. So how do we do that? As people who are so conversant with the internet and the use of the internet on our computers, how do we do that? We do this using a URL, a link that that we type, http://bigbazar.com/customers, and that's it. And so basically what we do is we open up a browser and we type this, and then Big Bazaar sends back information. So it sends back, again, it looks up like as a very nicely rendered sort of a page, and very beautiful looking Big Bazaar over there, and with lots of orange and blue that they use, that's their color. They have they'll give information about their customers, and they'll give a lot of other information, lots of pictures, lots of products, and it will be very appealing to the human eye. But that's basically the way it works. Okay, so it's a browser-based system where the person is using that browser, types in that URL, and gets information from Big Bazaar on its customers. All right. Now, the other thing that is also there that some of us may be knowing, some of us may not be knowing, is that along with this this very nice website that Big Bazaar provides, Big Bazaar also has APIs available. Okay, so what we can do is using another application, I can write an application that can pull information from Big Bazaar using these APIs. And because we are talking about RESTful APIs, we'll talk about how RESTful APIs do this. Okay, so let's say I'm working, I have my own system over here, and I want to pull information about customers from Big Bazaar's server. Okay, and when I was in front of the computer, I was doing it using a browser-based system where it gave me information. When I'm using RESTful APIs, I do almost exactly the same thing. This application of mine tries to pull information again using a URL, very much like the browser was doing when it was getting information from the Big Bazaar website. Now, there's only a slight difference. If you look at this example over here, obviously this is just an example, but most of the differences are like these. So if you look at this, is still HTTP bigbazaar.com, and then you have a /API that some way distinguishes from the normal request that the customer had made on the browser, and then it asks for customers. And then this application makes this request, and the Big Bazaar sends back information, and it is information that is in a nicely structured manner. Unlike in the previous case, where the information on customers was sent back in a very nice looking manner, with maybe pictures of a few customers, the star customers and all, with lots of information and something that looks very good. Here, what they do is they send back probably the same information. But if you look at it with the human being, we can actually look at that XML. It will look very boring. It will just be a bunch of text that is there and lots of information. But the thing about the information that gets sent back is it will be very, very nicely structured, very logically structured, so that the application that has made that request understands it properly and can make use of it. So that is basically what is RESTful APIs. So it's just normal URL-based request, and the responses come back in this manner. It's as simple and lightweight as that. So there are other ways of having APIs. There's these WSDL and this SOAP system. Those are also there. Those are also useful. Those are also based on XML. But the thing with them is they are pretty heavyweight. And the reason I'm talking about RESTful APIs is because in Internet of Things deployments, when we move from IoT to WOT, we need to have APIs that are very lightweight. And RESTful APIs probably give us that extra, that lightness that we require for such kind of resource-constrained environments. Okay, so I'll talk a little bit more about REST. So what are RESTful APIs? So the thing about RESTful, what makes them so lightweight is they use existing facilities that exist in the HTTP protocol. Okay, so HTTP is something that we know about. So that's the protocol that is used widely on the World Wide Web. And it has 4 methods that are there, verbs or methods, whatever you call it. One of those is get, put, post, and delete. And what these does is get enables you to read content, put enables you to update content, post enables you to create new content, and delete enables you to delete content. So these are known as the CRUD, or C for create, R for read, U for update, and D for delete. So the HTTP methods that are already there, that is used commonly on the internet, is what RESTful APIs make use of. And we'll see how they make use of this. And this is what makes them so lightweight. There is no extra requirement in putting together, in trying to communicate, getting one computer system or one application to communicate with other application, with another application. It can be done using the simple HTTP methods. All right. So we'll take an example. Now let's say we make use of get. Okay, and sort of aligning with the example that we took. So it's as simple as writing get API customers, and the response that we have over here is JSON. It is something similar to XML, but we get this kind of a response as JSON. So it's basically, it gives you information about customers. So let's say Big Bazaar has these customers. They have a customer ID 1, 2, etc., and all the names of those customers. So it is in this sort of a format, something in this along these lines, this sort of a format that the response comes back. Okay, and similarly, I can use the other methods. So let's say instead of wanting information about just one customer, about all the customers, our application wants information about just one customer with ID number 1. So what we can do is we can very easily, the URL is modified. Okay, so you have this URL that was initially API customers. We just put in a slash and we put 1, and the response is such that this the ID of the information of only customer number 1, the customer with ID number 1 is returned, and the rest of the customers are not returned. So we can actually, what the idea of showing this example is that this URL can be modified and the queries can be appropriately customized based on the requirement of the application. And this is again very much like we make requests. If you follow the URL that you have and you're using a browser-based system, let's say you're trying to look at Big Bazaar on the internet, you're looking at the Big Bazaar website. So let's say you ask for customers, you get information on customers, and then you'll have a lot of links on that website. Okay, so let's say you get back a lot of customers, and then let's say again they have customers have the customer ID number 1, ID number 2, ID number 3, etc. for customers. And then maybe in the normal browser-based system, the web application, you'll have a lot of pictures maybe of those customers, and there'll be links. So if you want more information about one customer number 1, you just click on the link with your mouse. All right, and what you'll notice is information on customer number 1 will come back, and that's pretty much what is happening over here. Except that the information that is coming back is not coming back as a nicely rendered HTML. It's coming back as a very structured and logical JSON format. It's JSON or XML, whatever they use, but it's going to come back in a structured manner. Similarly, we can you do a put over here. What put does is put can update content on the server. So if you have put API customers 1, and then you have the name. So you want to update. Let's say customer number 1's name is Abhishek Srivastava. That's me. All right. And suddenly I want my name to be modified a little. I want my name to also include Dr. Abhishek Srivastava. Let's say suddenly I'm very proud of the fact that I suddenly got a PhD, and I want my name to be updated. So I put in this. I put API customers 1. And then I put in the updated name, and that particular updated name is going to be reflected as part of the response. So that is what put enables you to do. This is a very, very simple and very trivial example that I'm giving over here, just to give you an idea of what RESTful APIs, the way they work. Now, similarly, we could have something like a delete. So let's say they want to delete, for some reason they're not happy with me and they want to delete my name from the Big Bazaar server. So I can do that, delete API customers 1, and I'm deleted from there, from the database. I'm out of there. All right. And something similar we could do post. So we can create a new customer. So post API customers and with the name, and then it creates this new ID 1 or whatever. Maybe ID 1 may be very simplistic. It could be ID 1000 and 1964, and then the name, etc. So basically, what we're trying to do is we are just using all of these verbs, the normal HTTP verbs, to extract information, to update information, to delete information or content rather on the Big Bazaar server, and that is basically how it works. So just for a recap of all of that, we've got get. We can get information like the customers and specific customers. We can put information. We can actually update certain customer information. We can delete information content from the server, and we can post. And all of these can be done by one application rather than us having to do it using a browser-based thing. The human does not necessarily need to be there in the. Okay, so that's basically what it is. So what we can use is, in order for RESTful APIs to be there, in order for Internet of Things to become Web of Things, we can make use of RESTful APIs. So what we can do is, for every deployment out there, we can provide them with a RESTful API, where if one object wants to one thing wants to interact with another thing, it can do it using this RESTful system that we just talked about. Okay, so it can send requests, it can get responses, it can get things to be done on these IoT devices. All right, and the intervention of a human being can be totally eliminated. We don't need to do it. And again, the other thing is, so that's the first thing. The second thing is you can have very loose coupling. So it can be one lamp that works on the Google ecosystem. You can have an Alexa device that works on the Amazon ecosystem. You can have a third device that works on the Samsung ecosystem or whatever. And then for all of these devices, you provide a RESTful API, which is technology agnostic, does not matter what technology you're using. And using these APIs, we can actually connect all of these devices, and it becomes a very useful sort of mashup that we can. Okay, so what we have is we have a mashup of things. So what we can do is all of these. This is a bit of a modification of the earlier picture that we had, where you have all these devices. So each of these devices that we have, that you see on your screen, each of these may have their own technologies, but then all of them, the common thing is they have a common technology abstraction that you can have. So irrespective of the technology, it's either REST or any other API that can be commonly accessed. And all of these, through these APIs, they're connected to the internet so that anyone can connect with any other one. So you can have this, I don't know, what is this, an iPod, and this is a television. These can be connected irrespective of the technology that they're using. And then you have this, these three devices getting connected irrespective of the technology. And you can have these, and you can do it in a very plug and play sort of a manner. You don't really have to have a developer coming in and writing hard code and doing a bunch of things. You can do it in a very, very seamless manner. It works very well for you. Okay, so that's the big idea, the broad idea of what Web of Things can do for you. Now, what are the applications? Oh, amazing applications, huge. I mean, the possibilities are endless. So and this example, I briefly touched upon it earlier, is if you have a smart city. So we are all moving towards smart cities in India. I think Indore is really high up there apparently in the smart city rankings, etc. We are pretty smart. And when we become truly smart, what we'll be having is we'll be having all of these isolated silos of IoT deployments. We'll have, maybe if you look at it, we'll have a mobility system, we'll have a transportation system which will be IoT enabled. We'll have a health system that will be IoT enabled. We'll have an energy system that will be IoT enabled. All of these different systems that make that are part of of a city will have their own IoT deployments. Now, the fact of the matter is, if we do it in a top-down manner, we'll have them all follow uniform technology, but that does not happen. Most of the times, you have a very bottom-up sort of a development where isolated systems. You have every system has isolated silos of deployments. So maybe the transportation system they are comfortable and it is convenient for them to use a certain technology. The healthcare has a certain other kind of technology. Maybe your energy system. This one. Yeah. Hello. Hello. Yeah. I'm making a presentation. I'm in a presentation right now. Can I talk to you? I'll give you a call. Sorry about that. Okay. So basically what you have is you have this transportation system that has a bunch of, maybe they are familiar with a certain technology. You have an energy system that has another technology or health system. But it is very important that all of these seamlessly communicate with each other. Let me take an example. Let's say you have a transportation system that has a bunch of IoT deployments, and where you have all the traffic lights being controlled by these IoT devices. All right. And you have a healthcare, you have a hospital infrastructure that has a different technology, and it has also a bunch of IoT deployments. All right. And you need the hospital system to communicate seamlessly with the transportation system. And a very good example is, the organ transplant thing. A lot of times they form these green corridors where somebody somewhere in Madras, in Chennai, requires maybe a kidney or something, or maybe a heart transplant, and there is a donor in Indore, and the donor and you just have to get the organ within a few hours to Chennai. and then you have to get it to the airport from a particular hospital in Indore, maybe in 15 minutes. Otherwise, that organ is going to get spoiled. So there, if you have a system, if you have a healthcare system with IoT deployments and you have a transportation system, and there is seamless communication between the two of these, it's going to make things very, very easy for the two of these, for that organ transportation, the green corridor to be formed. So those are the possibilities that will happen. But if you have isolated silos of deployments, it can still happen, but then you have to think about it much ahead of time. Okay, what if this happens and what do we do, etc. So that is where WOT is a very, very important tool to have. And this is just one example. There are so many examples out there where seamless connectivity between deployments is an amazing thing. It's an amazing sort of a facility that you want to have. Okay, so now I'll talk about a little bit of work that we are doing as part of the work that as part of our research here. And one of the things that we are doing is we are trying to. So I don't know if you've heard about Second Life. So Second Life is I have a video for that immediately after this. But Second Life is an online system. It's an online environment. It's an online world really, where you can actually have an avatar of yourself. So you are, let's say, Abhishek Srivastava has an avatar inside Second Life. And what I can do is, using the internet, I can connect with different people in different parts of the world in Second Life. So I can be walking inside Second Life. I can be, playing a game inside Second Life. I can be traveling inside. I can do a bunch of things inside Second Life. Now, what we are trying to do now, Second Life is there. It's part of this. There's this Linden Labs that has created Second Life. It's very popular. It has millions of, several millions, I think, of participants who are using it. And the thing that we are trying to do is, so in Second Life currently is a virtual medium. It's all virtual. It's behind your browser. What we are trying to do is we are trying to extend Second Life into the physical world. So you're trying to see that if something happens in Second Life, can it happen in the real world? And if something happens in the real world, can it be reflected in Second Life? That is what we are trying. And we are trying to do it through these RESTful APIs, through these WOT sort of deployment. So, but before that, I have a very nice video of Second Life that I've taken from the internet. I'll play that for you. Okay, this is what. So just in case you don't know what Second Life is all about, this video will give you a bit of an idea of what I'm talking about. All right, so I'm just starting the video now.
Second Life is an endless garden of creativity.
We are walking into a work of art created by the people who live there. We have the ability to communicate in a way that is very liberating.
When I started Second Life and saw everything that was capable of doing, that really struck a chord with me.
There's a freedom that comes from being in the virtual world.
Okay, so if you've not had a chance to go into Second Life, it's very exciting. You can you can get in and you can create an avatar of yourself, and you can do a bunch of things as you just saw. I mean, in fact, very interestingly, a lot of big companies, like I know for a fact Audi does a lot of advertisements in advertising of its product inside Second Life. So what you can do is, if you have an avatar in Second Life, you can actually test drive the latest Audi car that is coming. So instead of having to go to a showroom and driving the car and there's a long queue of people, you can actually do it virtually. And of course, it's not the same as the real thing, but then a lot of these companies are making use of trying to advertise the products through Second Life, and it's very nice. So if you've not done it already, you can actually go and experience this. Very nice. So anyway, so that was about what Second Life is. And what we're trying to do is, as I just said, Second Life is a virtual medium. It's a visual sort of a medium. It's behind your browser. What we are trying to do is we are trying to bring in melt that gap, melt that virtual and physical gap, and try to make use of these WOT ideas and try to connect the physical world with the real world. Now, how is that useful? I mean, of course, this is a very, very preliminary attempt that we are making, but the possibilities are endless. I mean, you can use the second life for all kinds of simulation activities. So what you can do is you can create a rendering of a particular city. If you look at that picture over there, that is a rendering of Berlin, the city in the capital city of Germany. And what you can do is you can have a rendering of the thing and actually try to simulate an earthquake. And then do some sort of shaking out in the real world and try to simulate it in Second Life and see what kind of destruction can happen. You can do a lot of simulation studies if there is this connect between the real world and Second Life. And of course, these are just one example. There's so many other possibilities. So again, there's another video of some work, very, very initial work that we've done. A few of my students worked on this. And what they've done is they've created a very basic rendering of a room inside Second Life. And then they have all of these is a simple microcontroller with sensors. And then they try to, first of all, light a candle, light a matchstick and raise the temperature. And then that temperature rise is reflected inside Second Life. And the second thing that they try to do is they try to create a little bit of a breeze. So they take a simple piece of paper and they wave the paper near the sensor, and then the paper creates some breeze, and that breeze is reflected inside Second Life. It's a very, very simple rendering. It's almost embarrassingly simple, but then it's a start. We feel is how do we connect this real world to the virtual world? So I'll just quickly run this video. So that's a simple a microcontroller with it's got sensors. And so let's say, so this is the Second Life thing has not yet started. So what they do is, first of all, they light a matchstick, and then what they do is so of course the temperature is increasing. That is very basic. And then now they will create a rendering of this is Second Life. So that's a simple rendering, okay, of Second Life. So we have a room which has a door, and then which has this large display thing over there. And what will happen is, as the temperature outside rises, because the sky lights this matchstick, the temperature that is reflected inside that thing gets changed. So that's again, as I said, it's very, very simple, but it's just a start that we are working towards. So again, I have to run the video again. Okay, so it's coming. It's repeating. So. So mainly what you do is you have this rendering, and then on that video you have this temperature that will change because of this. Okay. Now, and the second thing that he does is, the second thing that he'll do, and I'll just repeat that, maybe you missed that, the video could have been taken better. The second thing that he does is that with this large piece of sheet of paper, he creates some wind. Okay, so he'll wave the piece of paper near the sensor. This wind gets created, and in Second Life, you will see this door getting opened because of the wind. Because the first thing is the temperature thing that is reflected on the display. And the second thing is, so you can see that. So that door gets opened because of the wind that is created out here. Now, all of this is, it's just done through these APIs that they've created. Very, very basic idea, very basic implementation, but something that has potential nonetheless. All right, so now, so WOT is very nice, everything, but what is an issue with WOT? Okay, so one very important issue with WOT is the way it is, now some experimentally it's being used, and it's not as commonly adopted, but there are laboratories and there are settings where they make use of these. And the problem is these RESTful APIs are very heavyweight. Okay, so these actually require a lot of computational capability. So if you know about this, it's a Raspberry Pi. So something like that needs to be used. But that luxury we cannot always have. I mean, if you have a deployment that is at home, you can use a Raspberry Pi, or you have a computer system at your disposal. But if you're talking about very remote locations, okay, where you have IoT deployments, let's say, for example, a wireless sensor network deployment, which is also an IoT deployment, where what you can have is, what you may have is, you may have that WSN connected to the internet, but you do not have the luxury of, because it is such a resource constrained device and it is powered by these batteries, you cannot be running a Raspberry Pi over there. So you need to have a very, very small, very low powered microcontroller. And so it's very difficult for you to actually implement a RESTful API on top of that device. So what do they do about that? So there are other technologies that permit this kind of a technology agnostic nature. And one example, I'm just talking about one example, is a 6LoWPAN. So it stands for, I think, IP version 6 over low powered wireless personal area networks. Okay, so this is one example. And what 6LoWPAN does is, the problem with all these REST things is, you're talking about, let's say an IoT deployment is in a very resource constrained environment with very little processing capability and very small memories. How do you? So in 6LoWPAN, what happens is something like, so I'll just try to first explain how these communications work. Okay, let's say you have a packet that needs to go from one end to another end, one node to another node. So the way it works is, a very, very simple depiction is, it goes through the different layers of the stack, the internet stack, and basically what happens is, you have some data, some content being added to that particular packet at the application layer, something happening at the transport layer, something maybe happening at the network data link, and then at the physical layer, that packet with all of this additional information and content and data, it gets sent from one node to another. That is how communication works, and that is how, these WOT that are enabled through RESTful APIs, that is how they work. So they have all of this information with all of these extra sort of add-ons, and then they go from one node to another. Now, how does 6LoWPAN differ? So that is how WOT works. How does 6LoWPAN differ in this case? So what happens in 6LoWPAN, I'm talking about it at a very, very high level, is you have something like this. Your gateway is in a normal WOT, it's the application layer. And in this case, what happens is, it is this 6LoWPAN. There is a layer between the network and the data link layer. That is the gateway in the case of 6LoWPAN. And we'll see how it works through a very simple example. Okay, so again, let's say we have something like this, and we have our packet that needs to get across. So what happens is, at the application layer, you have some content added, and transport some content, at the network some content. So it's a pretty big packet by then. At the 6LoWPAN layer, what happens is, all of these get fragmented to very, very small, very small packets, all of them. So that even if you have a very resource constrained IoT deployment, it does not matter, because these are small. I'm just talking about 5 fragments. Maybe you have a large number of fragments, but very small fragments that can very easily be handled by those resource constrained devices, and then goes through the data link, and then the physical layer, it gets across from one node to the other. And that's pretty much how simple it is, and it becomes very useful. So WOT RESTful APIs are not the only way. There are other technologies that are coming in more and more. Just touched upon one example of how it becomes possible in IoT deployments. All right, so it's 6LoWPAN, like REST is portable. Does not matter what technology you're using. You could be using Wi-Fi, you could be using Bluetooth Low Energy, you could be using IEEE 802.15.4 Zigbee, etc. And all of these can make use of 6LoWPAN to communicate with each other in a seamless manner. It becomes a very useful sort of a thing to connect different deployments with each other. Okay, so that's it for my talk. I'll just summarize what we talked about. So IoT is definitely a very, very important part of our lives. It's there. It's going to be there for as long as we can think. It's going to be very useful. It's going to make our lives very comfortable, and it's here to stay, as I said. And the thing with IoT deployments, currently it is meant for mainly human consumption, and these are very tightly coupled systems. So what we mean that by that again is that these are meant for individual silos of technological silos. It's very difficult for you to connect one to the other seamlessly, or it is meant for human consumption. These are the two things, and WOT makes this possible, overcomes these limitations. One, it's such that it can very easily facilitate machine-to-machine connectivity. We don't necessarily have to have a human in the loop. It can do away with that. And the second thing is it permits loose coupling. So you can have seamless connectivity between individual technologies. It does not matter. You not necessarily need to be married to a particular technology. You can have any technology. It can connect with each other in a seamless manner. And WOT, the way it's being currently used, let's say with REST, etc., it does become heavy and may not. For normal deployments, it's okay. And like for example, in your homes, it's fine if you have a normal RESTful APIs for these WOT. That's fine. But in resource-constrained environments like say WSN, it may not be the best idea. So you have other technologies out there, like 6LoWPAN is something that really permits very good connectivity between different deployments. So that's it from me. Thank you. I think we have time. I had until 4 o'clock, so I think we have 15-20 minutes left. So thank you, everyone. If you want to discuss something, I'll be happy to discuss ideas. And if you have questions, I'll try to maybe address your queries if I can. So I'm done. Thank you. Thank you, everyone, for being patient. Thank you.
Dr. Abhishek, I have one question.
Yeah. Please.
The question is about the second life thing. So you showed that it looks like something like, graphical animation type of a thing.
Yes.
But so what it can be used? I mean, to me it seems to be a little bit of a fantasy type of a thing. But I mean, so
I think now what is happening is, in fact, a lot of simulation studies are happening in Second Life. Okay, because Second Life we can render anything Second Life. In fact, in civil engineering, they're using it more and more for depicting. Let's say they want to construct a township. Before they construct it in reality, and to give people a feeling for that particular township, they're using Second Life, or where people can have avatars. They can actually go and the thing about Second Life is it can be very detailed. So the abstraction can be the entire township. If you're talking about that, you can have in individual buildings. You can actually enter the building. You can actually have rooms. You can have furniture in the room arranged. So all of these things can happen. So that becomes very useful. Now, the thing about it is right now it is all very virtual. Okay, so it can only do it behind your browser. Can we not make it physical? I mean, can we not do something in the real world and have that be reflected inside Second Life, and it becomes useful for such studies? So I think in simulation studies, it's something that has a lot of promise. Of course, it's just the tip of the iceberg right now, but lots of promise in that respect.
Okay, thank you.
Okay, thank you, sir.
Yes. Any other question? Any other question? Participants, if you have any question, you can ask.
Okay, regarding the 6LoWPAN, you said that actually the payload size will be smaller, as I understand.
Yeah.
Okay. So, which means it's, and then you said, but the major advantage is, I mean, all technologies can be, can interoperate with each other if they incorporate 6LoWPAN into it. Right. Okay. Thank you.
Yes, sir. Okay, so any other question from participants? So now I wish to thank Dr. Abhishek Srivastava, who has accepted our invitation in a very short time and explained very useful things. The advancement of IoT into WOT, the wave of things, starting from the concepts of IoT, he has raised the subject to WOT level. Something like 6 law pan, however, we are not students of computer science, so we could understand a little bit of it. And I understand the problem of those who are deeply connected with only telecommunications may get certain problems to understand, but this is what the scenario is going on. Truly speaking, this is information communication technologies era, so that nothing is now separately called to be distinguished. Everything is mixed up. So now in this era, such things are lifting our consciousness to that level, and therefore it is very necessary for us all to get updated and at least have some information about that. So I thank Dr. Abhishek sir for the useful information that he has given. Thank you, sir.
Thank you. Thank you very much. Thank you for giving me this opportunity. It was a pleasure to do this. Thank you very much.
Thank you, sir.